Hi students, Bowles here, just doing a quick review of equilibrium for you guys, for those that are wanting to study and review. Keep in mind, equilibrium is a dynamic process involving continuous change. You have a forward reaction proceeding and a reverse reaction proceeding at the same time, simultaneously without stopping. And keep in mind that what is equal at equilibrium is the rate. The rate of the forward reaction and the rate of the reverse reaction are equal, so they're occurring at the same rate. And it looks like nothing's changing, but in reality, it's dynamic or constantly changing. Remember that word dynamic. It's an important word, and the reaction rates are equal. Reaction rates are equal. So keep in mind, reviewing Le Chatelier's principle is when a system that's at equilibrium is placed under a stress. And keep in mind what those stresses can be. They can be things like heating and cooling, adding a product, a reactant, removing something, or changing the pressure. So according to Le Chatelier's principle, when you're adding a stress to a reaction, that's going to cause a resulting shift. Because according to Le Chatelier's principle, your system will readjust to counteract the stress. So keep in mind for Le Chatelier's principle, if you add something, it goes away from the substance you added to rebalance its equilibrium in a new way. If you take out something, it will go or shift toward the thing you took out. Toward. Sorry about the mess here. So add, away, take out, toward. That's your key. A and A, T and T. All right, add away, take out, toward. So in this particular equilibrium, what will happen when you take away or remove some H2? So you're removing this right here. Remember, this system's in a container. There's a forward reaction occurring and a reverse reaction occurring at exactly the same time at equal rates. So if you remove some H2, the system's going to shift to the left to make more H2, favoring the reverse reaction temporarily and then readjusting to a new equilibrium. What if your stress is to add NH3? Then that would be add away. When you add something, it goes away from what you added, so that'll be also a left favoring the reverse. Remember, add away, take toward. So when I took out the H2, it moved toward the H2. When I added the NH3, it moved away from the NH3. What about heating? Heating is unique, but remember, when there's heat in the system, you just look for the heat. So heating the system means adding heat, therefore it's going to shift to the left, reverse. Adding N2, it's going to shift to the right, because remember, when you add, it goes away from what you added. Increasing the pressure. Whenever, you need to keep in mind, whenever pressure increases, it always readjusts to the less moles of gas. Remember, only gases are affected by pressure. It will readjust to the less moles of gas. Why? Because you've effectively taken the system in a closed container and you've pushed the lid down now, causing the lid to be shorter. And now those particles are trapped in a smaller space. So because of that, they need to try to relieve the pressure by shifting to the least moles of gas. This side, by the way, this is a gas. This is a gas, and this is a gas. They have to tell you that, otherwise you won't know. So if you increase the pressure, the less moles of gas will be on the right. So that will shift to the right. I hope this helps you as you review. Remember, the opposite is true for cooling the system. When you're cooling the system, it's like taking away heat, which would cause a shift to the right. And decreasing the pressure, it will expand to the more moles of gas. Hopefully that helps you, and good luck on your quiz, my chem friends.